Hello, everyone, and thank you for joining us today. We have a special presentation, Designing for Drought Conditions, presented from our friend Dariush. Dariush received his PhD in soil science. Before that was his master's in soil and water engineering. He's done quite some amazing things over his career, including professor at the university level. Uh, Now he is a consultant for Eco Consultant, which is his company, where he is designing irrigation systems based on science and evidence. So, without any further ado, I'm going to hand over the presentation to Dariush and let him give you a little more information. So, Dariush, take it away. I'm going to change my screen over now.
And thank you. First of all, I would like to express my thanks to Landfix team that they gave me this opportunity to talk about this subject, because unfortunately I have been trying to bring the subject of water deficiency to the view of the many people, politicians, and many landscape designers, and but nobody listens. The only organization that is listening to me is Landfix, which I want to thank everybody in that organization for this opportunity. So what I'm going to talk today is about drought. First of all, what drought is and how we can prepare ourselves to go against drought. Unfortunately, the system does not. I'm talking about California. I'm not going beyond that. The system in California, I'm talking, the system are the water authorities and also the government agencies do not to recognize, or they recognize but do not want to admit that we have always been, from the 100 years ago to this point, in drought. In order to prove that, I went to the database in Davis, California. I could do that. First I started with Glendale in Southern California, but I thought somebody will come and say, okay, this is Southern California, why you are talking about California and you're bringing the data from Southern California. So I went to Davis data. The data on Southern California is available to me. Anybody wants it, you can send me an email. I'll be more than happy to send it to you. And I did some studies from 1983 to 2013, and I will show that to you mathematically later, that drought is not a new subject. So in today's presentation, I put up some objectives. So my first objective is to point out and emphasize that California drought is a permanently existing natural feature. It doesn't change. The drought condition is not changeable. Unfortunately, we, the people of California, should accept and manage our lifestyle accordingly. We cannot go against it. We have to prepare ourselves to go with it, of course, to go with it without hurting us, which is possible. Unfortunately, during the many years, we had water in Northern California, we had money in our system, so we were buying water, bringing here, and we were telling the people we are out of drought, so use as much as water you want. When you were driving by the freeways, the big irrigation heads were planting ice plants on the slopes, and water was running in the freeway, damaging the freeway asphalt and concrete, and we were happy that we are out of we are not in drought, because we thought that we have water, but we didn't have water for many years. And so it is, and the green industry in its professionals, which is including the landscaping designers and advisors, etc., should educate them about the soil-water plant relationship in our area which is always facing the drought. The second objective is to understand that during the drought, the solution to water shortage is not to cut off water or reduce irrigation. We have to water correctly. Unfortunately, yesterday I was driving in several freeways going from Riverside to LA and coming back, and I noted that on the big screens on the side of the freeways, it's written, "We are in serious drought condition, save water." We have been in serious drought condition, and drought condition is not mild or serious. Drought condition is drought condition. Somebody should know that. So why I'm sharing this information with you. And the other thing is to find out the plant water need is equivalent to the amount of water that plant is using or evaporating or sending to the atmosphere through evapotranspiration. So we should not water above that, because watering above that is wasting of water, and watering below that, it will kill our plants. I remember I had a landscaping I still have the company, and I was doing public work, and I did many of the freeways, a part of the 405, a part of the 75, and all of that. And I remember that at that time, they were insisting, although I was trying to stand against it, to use the most amount of water that's possible, because unfortunately, majority of irrigation companies, salespersons were coming to the designers and pushing their products to them to be sold. And again, as I said, we were driving by the freeways and water was all over the freeways, and also when you were driving by the parkways in the street, water was all over on the streets, because they didn't know how to irrigate the slopes, how to control the amount. They were just putting too much water, and at the beginning of any landscaping project, the plants were green and nice, and in 6 months they were gone, because the water that was applied was not used. And the third objective is to recognize the water, as I mentioned this before, according to the rules of soil, water, and plant relationship. One plant needs more water than another plant. This is soil-water plant relationship. The soil density is different. A soil with a higher density is more compact, so it absorbs less water. It causes more runoff. We have to consider this. When I was doing this in these projects, always on the big plans, there was a note that the contractor is responsible for taking samples and taking samples to the laboratory, etc., etc. We were supposed to take a 6-inch sample, take it to the laboratory. The contractor was supposed to get $200, $500, $300 to run it, and nobody was even looking at it. And I'm telling you, the sample from the first 6 inch of the water of the soil does not mean anything anyway. So it was not helping. So that is the responsibility of the designer to design in a way that water is added upon the plant needs in relation to soil condition, which I'm going into it. So we have to use the minimum, do that with the minimal waste of water, and of course free of contamination. I remember one of the cities that I was doing project for them, they invited me as a consultant, and I went there. There was so much fertilizer used that the nice soil in Southern California was turned into a salt marsh. Now, today I'm going to talk about this subject. Is there any question up to this point or not, Brian? Okay. This is what I'm going to talk about.
Yes, there is, Dariush. Sorry, I was.
Please.
Hello. We do have We do have one question, and it's from another professor, which is, what is your definition of a drought?
I'm going to it in a second. I'm
Okay.
going to into it to a second by showing a diagram. Okay. Thank you very much for asking me this question. Okay, so in today's related terminology, I'm going to first of all, I'm going to use some terminology that I'm going to discuss about them, and then I talk about what is meant by drought, which I'm using the customary and understanding of drought and the numerical and visual approach, and then how to go against drought. There are elements that to be considered. That is, there are plant factors, soil factors, and then I will make some recommendations. But most of the data that I'm giving today, or recommendations that I'm giving today, are most in relation to the soil factors. So stay with me. Now, just terminology, I like to talk about bulk density. Bulk density is the density of the undisturbed soil. Bulk density is the index for the soil compaction and aeration. The larger the number of bulk density, it means that the soil is more compact. This is completely different the way that the engineers are using. They are using the percent of compaction, but we use bulk density, which is more numerical and more scientific. And then the canopy, which simply the percent plant shading. If we have plants covering an area, if we have 55% of the area covered with those plants, we say the canopy is 55%. And then we talk about runoff. Runoff is the movement of water from the source on the surface as affected by the slope and also the compaction of the soil. And then I talk about precipitation, that is the rainfall and snow and other precipitations, which in Southern California we are facing with rain, if any. And then WI, that is water intake, that is the vertical movement of water into the soil, which is measured in inch per hour. So please remember that all of these, precipitation, evapotranspiration, water intake, and here I have evapotranspiration, that is the sum of evaporation from the bare soil plus the transpiration, that is the movement of water from the root to the body of the plant, going to the stomata or the pores on the leaves of the plant and going out. And so all of these, evapotranspiration, evaporation, transpiration, evapotranspiration, precipitation, all are measured in inch per a certain duration, which can be month, day, week, or year, and it might be used centimeter or inches or foot, any height. So it has to be consistent in all of these variables. Now, what is meant by drought? I went to the dictionary, I went to the thesaurus, and I got these: lack, dearth, I don't know if I pronounced it right, D-E-A-R-T-H, deficiency, or famine. This is what I got from thesaurus. But unfortunately, none of them are relating this deficiency to water. So if we want to talk to water, we should define it some way better, which I don't know yet. But I went into it and I came up with some kind of definition for myself that I'm going to introduce to. Most of the places, the drought has not been defined quantitatively. So it's not quantitatively, it is just drought, the word drought, D-R-O-U-G-H-T, that's it. And so the understanding of a farmer is different from a landscape architect and from a politician and from a business industry. And unfortunately, business entities and politicians are taking advantage of this vagueness of the definition of drought. California excluding the high altitude regions, is in arid region climatically. Arid regions are the regions that the total precipitation is less than 10 inches. Less than 10 inches. I will show you that many of the years we have rainfall below 10 inches per year. And the data from CIMIS, that is the California Irrigation Management Information System, proves that. If you go, you can sign in their website, and every morning they will send you the information about the last 24 hours if you want, or they will send the information last month, etc., etc. They are very helpful. All right. Anytime someone asked me the definition, to me, anytime that the amount of precipitation is less than amount of reference evapotranspiration, we are in drought. That's very simple. That's numerically. So somebody may not agree with that, but I believe that is true. And our job when we are doing irrigation, the purpose of irrigation is to fill up that gap, the gap between the evapotranspiration and the annual precipitation. When I went into the CIMIS data for the year 1983 to 2013 in Davis, California, I summarized the data on this diagram. Brian, is this diagram clear?
Yes, it is.
Okay. The red part, the red columns are showing the amount of evapotranspiration per year. So the first line on the left in red color is the evapotranspiration for the year 1983, and the one on the right is 2018. And then the blue ones are the amount of precipitation for the same years. The one in blue, in green, unfortunately, green is good news, but Excel didn't give me another option to use another color, so it is green. The lines that are negative in the bottom of the diagram are showing the shortage of water. That is very interesting, that the shortage of water in 1983 was minus 50 some, or maybe 50 inches, and in 2013 was almost minus 60 inches. 60 inches means 5 feet of water. So if I go deduct or subtract the amount of precipitation from the amount of evapotranspiration, I get this negative number, which is the shortage of water. That's the amount of water that we need to add to the soil. So at least for the year of 1983 to the year of 2013, according to this diagram, we have been in drought, even in Davis, California, which is much better than what we do in Southern California. Did I answer the question of the professor who asked me the question? Does he have any input to add to this and help me with that, or I just continue?
There's no questions and no comments so far, so I'd say go ahead and continue. It's
okay.
Super beneficial.
Now, knowing that, we have factors that are important to consider for water efficient landscape design. These factors are plant factors that are plant species. That means that one species needs more water to grow than other species. And then planting density is the number of the plants per unit space. The more the number of plants, the more would be transpiration from the plants, although it's reducing the evaporation. There is a number, there is an idea that I do not personally, as a soil scientist, agree with it, and that is if the canopy is 75%, evaporation is 0. That's not acceptable at all. And I contacted many of the universities to see if there is any new research to go against that very preliminary idea. Unfortunately, I couldn't get any answer from the universities, and since I'm not in research myself anymore, I cannot do anything about it. And then the third factor is the microclimate. If the location of the landscaping area or agricultural area is subject to very intense wind or many other things, then that has to be considered when we are planting, designing our planting or irrigation system. So these are the plant factors. So in relation to that, okay, evapotranspiration is the amount of water that evaporates from the surface of bare soil plus the amount of water that goes out through transpiration. Transpiration is a natural occurrence. Every plant is doing that. Takes the water from the root and takes it to the leaf and send it out. It has to do it because it needs the water for turgidity, turgidity, which is the strength of the plant stands straight, and also to keep the tissues moist and bring the nutrition to the leaves, etc., and do the production. So these three factors that I said, they are affecting the evapotranspiration. Now, evapotranspiration for a particular plant species. Evapotranspiration as a reference is normally measured on grasses. So every time that you see ET sub 0, it means the evaporation of a reference area that is grass. What they do every morning, they measure the weight loss of the plant and see how much plant has sent water from the soil. I don't want to go into techniques how they do that, but each plant, and we consider that one for the grass. We consider the evapotranspiration for water is 1, which is the reference evapotranspiration. Now, if we go for other plants have the system, the regional normally research places have come up with numbers with multipliers that if we take that multiplier and multiply by the evapotranspiration of the area, it gives us the evapotranspiration for that particular plant. For instance, if ice plant, the multiplier is 0.75, so and the evapotranspiration of the area is 0.95, so if we multiply 0.75 by 0.95, it will give us the evapotranspiration for that particular plant that I arbitrarily picked ice plant. So, and now we have landscaping coefficient, which is applying to all of the plants in our landscape area, which is manipulated or determined by a species coefficient, by density coefficient, and by microclimate coefficient. For evapotranspiration for a landscaping area is equal to K sub P times K lab sub D times K lab MC. Just keep this that much only, because if I want to go that, our time will not allow to go to the other subjects, which are the soil factors that I have very interested in. Now, the soil factors are extremely important and nobody cares. And I invited our council person, I contacted many times our environmental committees of the district that I was living here invited them. Let me give them a lecture. Let me give them some information. They did not even allow me to go in there. And finally, our council person came to the city that I was living, the town that I was living, Lakeview Terrace in California, and he just listened to me, and then they completely hijacked my presentation and went into the subjects that he wanted to talk about it. So I'm proud, I'm pleased that I have the chance to talk about this subject. Okay, the land factors that are very important to me. One is the land slope or the surface configuration, and then the soil physical properties that are texture, structure, and bulk density, and also the evapotranspiration and is affected, or the usage of water is affected by soil chemical constituents like salinity and sodicity. If we have too much sodium in the soil, the permeability of soil decreases. So instead of water going inside the soil, runs on the surface. And then soil mineralogy. We have different clays in the soil. We have soils that are expansive. When they receive water, they blow out and close all of the pores in the soil. They don't let water to go inside. So for the first 5 minutes of irrigation, they are good. They absorb water. But as soon as we go, for instance, to 5 minutes to 8 minutes, then they block all of the pores and water starts running on the surface. To me, as a scientist, as a designer, I believe that the designer has to look into these variables. How we can do it? It's very simple. There are soil reports for every county. If somebody, and I think everybody should be interested to go www.nrcs.usda.gov and go into the soil series that your project is going to be performed on that series, and read about out of these things. It tells you if there is a hard pan in there which may stop you from watering, going water to go down. If there is expansive clay or it is very sandy, all of this information will be there. We don't need to take a sample from the 6 inches of the soil, which most of the time has been disturbed, which most of the times the person who is taking the sample is not a professional, doesn't know how to take the sample, and 6 inches of the soil sample, especially undisturbed sample, does not help you, because you cannot measure bulk density that is a reference to the compaction on a disturbed soil. So it's just total waste of money and time for the contractor, and it's not useful for the designer. I give you some information here that is extremely interesting. Is there any question up to this point, Brian?
Let's see. Nope, no questions still. I think that the explanations are pretty in-depth. So
thank you very much. If it's not clear, please let me know. Okay, let's talk about the soil. Soil type is the texture of the soil on the first horizon. So we have soil series, that is the smallest class in the soil, and then we have soil type, which is the series. That series divides into soil types by the surface texture. So a soil is, say, UCLA series, then we may have UCLA sandy clay loam, which is a soil type, or we may have UCLA sandy loam, which is another soil type. Okay, so the series are the same. Now, so soil type, if it is coarse sand, medium sand, etc., etc., now look on the horizontal slope. If the slope is 1 to 4%, 5 to 8%, all the way 16% plus. Remember, before I explain this, remember that majority of the slopes are 2 to 1 slope. It means that the longitude of the slope is twice the vertical height of the slope. If you look at this, if we take the slope is vertical divided by line along the horizon, so they are 0.5. It means that they are 50% slope. So all of them are much higher in the slope than this table. And this table was I took it from one of the publications of Toro, and it is reference to USDA. So it has merit, it has scientific base. Now let's look at the first soil, that is coarse sand. The amount of intake, this means that this soil, if we put water on it and its slope is 1 to 4%, it takes 1.25 inches per hour. Now, if I go toward the right of the page and I go to the slope of 12 to 16, you see that 1.25 drops to 0.5. It means that the difference between 0.5 and 1.25, where does it go? It goes to waste. It goes to waste. If I take the same thing and go down, I don't know if you see clay or not. I can hardly it on my screen. Okay, if I go again to the 12 to 16%, do you see the clay along the line that the clay is showed? All right, if we go under 12 to 16 and look the number corresponding to clay, we see 0.05 inches. So if we have a coarse sand at 1 to 4%, it's taking 1.25 inches per hour. But if we have a clay soil on the slope of 12 by 6 to 12, say, percent, it is 0.05 inches. Where is going the difference? The difference goes to waste. I took this and I made a calculation and I looked at the percent loss. All right. If we go again to coarse sand on the left top, which has the highest infiltration rate, and compared with the clay at say 13 to 16 inches, we get to the number 96. What does 96 mean? 96% of the water go waste. When we were driving about 10 years ago along the freeways that we have a lot of water, all of that water, up to 90% of the water was going on the freeway. That's why today we are in such a shortage. That's why we are today, and nobody cares. I remember I had a contract with one of the cities which put me in bankruptcy. There was a slope which was 2 to 1, and I had to plant ice plant, and they spraying heads that they were gear driven, and they were producing about 3.5 gallon per minute. So all of that water was coming on the slope, going down in the bottom of the slope and moving there. And unfortunately, I had argument with the city officials, with the city engineer, with the person who had done the design. He did not cooperate with me to make any changes. Fortunately, I was wise enough to send a letter to them and said, if this is not working and causing any trouble, I'm not responsible for it. And then later they were going to sue me, and that letter helped me, and that I got out of it. So this is very interesting. So suppose we have a 1 to 4 inches percent, and we have a fine sandy loam. 50% of the water will go waste. All right, and if at 1% slope, if I go to 15% slope, 80% of the water goes waste. This is something to be very, very important to be considered. This was a very important table. Is there any question about it? Because I beg the designers to look into this and go into soil survey reports by USDA, which is available for every county in the United States. And you can even order the book. It's either free or they charge you only for delivery, or you go to the USDA database and find out how much, what kind of slope you have there if the soil is bare, is not touched yet. But if the soil has been graded for some reasons, then you have to go to a grading plan, find out the slope of the soil, combine that slope information with the texture information, and see how susceptible you are to runoff. If I want to use these numbers, if the loss is 70%, so efficiency is 30%. So if you are using the irrigation efficiency, is the amount of water that you have divided by 0.3. You see that how much water you really have to use to get to the amount of water that you require. Everybody was using that amount of water without knowing what they are doing, because as I said, water was available, but not through precipitation, through our pockets, through our money, and through this Northern California, which is not available anymore. Okay, now what to do? Select plants with suitable characteristics to resist the drought condition. If at this point I bought a new grove here in Riverside, I moved from LA here, and it has a big yard. It is all Bermuda grass. I'm removing it because it's not time to water Bermuda grass. Bermuda grass also is a warm season by definition, but it's using a lot of water because its root goes down to 3 feet. So I'm removing it. I cannot water Bermuda grass. I don't water Bermuda grass. I get rid of it. I prefer to water my oranges rather than my Bermuda grass. So if you have to use it, if you cannot convince your owner or the person who are doing the design for, please use either one of the warm season grasses like zoysia, like Sanacastine, like centipedes, etc., which I'm against all of them anyway. So this is one thing to do. Do not plant ground covers with continuous canopy because it causes high transpiration. For instance, no more ice plants on the slopes because ice plants has a very high canopy, and majority of the water that is sprayed by the sprayers go on the leaf without going down to the root. They either evaporate, or whatever goes on the slope goes down the drain, down the slope and goes waste. So be careful. Fortunately, at least Caltrans has stopped watering all of the ice plants, but that doesn't do any good because we don't have any. I sometimes ago suggested Caltrans to use garlic because we are importing garlic from many places in the world, and their quality is not as good as our garlic. I said, why don't we, instead of ice plant, use garlic, because it's a very nice plant, and we can use it at least to pay for the water. And nobody cared again. I don't expect that. Okay, what plants with thick and wide leaves? They are causing high transpiration, which is high, and when they come to the surface, they go through evaporation. and plant the single plants with appropriate distance so that the bare surface does not exceed 25% of the planting area. I put this, although I don't believe in it 100%, based on the recommendation that has been forwarded several years ago by some of the research universities. Okay, I came up with a example here. If you look at in this table underneath, if I have sandy loam and I go and pick up a nozzle, before saying that, let me tell this. Install the nozzles or the irrigation heads that their precipitation rate is less than the intake rate. If you look into the catalogs of any of the suppliers, big suppliers, I don't want to bring any name up, you will see there's a table that gives you the performance information about the heads, and then at the right hand normally they have precipitation rate for the triangle and also for a square. If you put the heads in a square shape or a triangle shape, the precipitation rate differs. So look at there, and also look at the intake rate of your soil, which I told you you can get it from USDA. Then pick up the heads that have a lower precipitation rate than the intake rate of your soil. Here's an example here. For instance, a soil is sandy loam. A slope is 7%. Intake is 0.3 inches per hour. Now, if a type of nozzle for a particular type of head is number 1.5, it's just a commercial number, it is, and that nozzle at 25 psi and radius of 33 feet in triangle form, it gives you it gives you a precipitation rate of 0.2 inches per hour if it is used in triangle, and if it's used in a square, 0.23. Look at 0.23 and 0.2. Both are smaller than 0.3. Am I clear on that? So it is good to accept this, because both of these numbers, doesn't matter if it's triangle or square, they are both smaller than intake of the soil. So when the system is watering, as soon as it waters out, the water goes inside the soil. But remember that after a short time, soil gets saturated and water starts moving. So you have to manage your cycle of watering to water and then stop, water and then stop, so that the soil does not saturate and all the water goes inside the soil. Now if I go and use the same type of head, but another name, another type, the same type again, but another nozzle, which is called nozzle number 5, you see that its triangle precipitation rate is 0.51 and a square is 0.59. This 0.59, 0.1, both of them are more than 0.3 on sandy loam. So both of them have to be rejected. The same manufacturer, the same kind of irrigation head, but different nozzles. You must be very careful. I must be very careful. Contractor must be very careful. But it's a big, big load on the shoulder of the designer to go after this variable. How are you doing now?
So yeah, we have a couple of questions for you.
Please.
Okay. One question was, can we post the USDA website information on land effects? And yes, we will. We'll post that once we.
And it is on my, I'm sure that this webinar will be on your site anyway. It is there, so they can go back and check on it.
Correct. Yeah. So we'll do
Yeah.
that, and then
And if it sounds, I apologize. Send me an email. I will answer these kind of questions very easily. Okay?
sure. And
Go
then
ahead. Sorry.
one last question is, how about mulch? Have you studied or seen research with mulch and a reduction
Well,
in evapotranspiration?
I personally, you may laugh at me. I personally, I don't believe that the problems that mulch is bringing always is helping that much, because if your soil is not permeable, remember, the term mulch. I must distinguish between the term mulch and the term compost. The term mulch means surface coverage. And unfortunately, we all go to the local city area and we get the vegetative pieces and spread on our soil. It may reduce the evaporation, but it is also preventing the water to get to the soil too, because it, especially when you are using a sprayer, sprayers are watering, and mulch has the ability to hold the water more and keeps the water and then release the water to the sky, I mean to the environment very easily, especially at the time that we are in drought and we are trying to be careful about waste of water. So I don't think that mulch is helping that much unless it is incorporated in the soil. Then at that time I call it organic amendment or compost. It has to be incorporated. It has to be mixed with the soil surface. Yes, that helps because it increases the permeability of the soil. So that intake rate that is 0.3, it may go to 0.4 or 0.5, and in that case, that 0.4 and 0.5 will be easier to manage than the 0.3. Yes, mulch doesn't help, but composting and incorporation of if you incorporate mulch inside your soil, then it will be helpful. Yes.
But
Anything
okay,
else?
so then one question that comes from that is, doesn't mulch reduce the weeds that compete for water in the soil?
Oh, it is increasing the weeds. It's increasing the weeds because okay, I have Bermuda grass right now. I'm removing that. Removing is may go into the dump in the city. The city goes and crash this and return it to the people. All of the seeds of Bermuda grass will go to the people. And for this reason, I decided not to send it to the dump. I'm going to dry it in my backyard and to prevent it. But not everybody is doing that. No, mulch is causing a lot of seeds to grow, and I regret only one time I used mulch in my house, and believe me, I was in house, and that was 16 years. I could never get rid of the weeds that they were growing because of that. Yes. So municipals are doing mulching and they are advertising to get rid of them, but unfortunately they don't heat them, they don't kill the seeds, and they cause a lot of problem with bacteria also. Did I answer the question?
I believe so. Let me see here. We got a couple questions that are coming in. Okay, and so yeah, that last thing was just again about mulch. Would be is there any exceptions to that rule if there's a certain thickness to the mulch to where the water is able to permeate through the mulch bed
No,
before being evaporated?
no, no, because it's depending on the amount of water that you put and the sunshine radiation, of course. If it is thicker, it will hold the water more and longer before being evaporated. But remember that when it is thick, it's holding more water too. When it is thin, it's holding less water and emits the water to the environment quickly. If it is thick, it holds more water and emits to the water gradually. Yes, if the water is permanently coming to the mulch, it is helping. It is helping. So some of the water from the mulch goes to the soil. Remember that the mulch has to be in very tight contact with the soil, because soil has a absorption capacity that is much, much more than mulch. If the mulch is in a tight contact with the soil, yes, water goes from mulch to the soil. That's why I'm saying that it should be incorporated in the soil. When it is mixed in the soil by a rototiller, etc., then the moisture that's absorbed by mulch, which we call it now compost, go inside the soil and do not evaporate easily. It's yeah.
Okay, so I think that seems to be all the questions. Go ahead and continue. Thank you.
Okay, now to me at this time, and with all of the problems that we have, the best solution to evapotranspiration is to use drip irrigation. And if you want to use drip irrigation, the same information that I gave you will apply to the drip irrigation if you put the drippers on the surface of the soil. The soil should not get saturated. The slope should not be high. If your soil is very slopey, either you have to put very low emitters on the surface and water very gradually, which has other problems, or put the water under, the emitters under the soil. I had a pomegranate grove in Little Rock, California, which I created. It had, for myself, it had 140 pomegranate trees. My water bill was only $85 a month because I put my irrigation system 8 inches below the surface, and my plants were growing beautifully, and I paid only $85 a month. And so putting under the surface will help a lot, but it is a very technical work. Somebody has to calculate, make the necessary calculations, consider the water absorbance and all of that, and that will work. That's the only recommendation that I make for this time and this situation of drought, to use drip irrigation, and if you are on a slope, use subsurface irrigation. If you want my name and address and everything, as on the first presentation page on this PowerPoint, you can always call me with my phone number. I'll be more than happy to help you, and also or send me the email, and I will be happy to help you. Again, my name is Dariush Bakhtar, and thank you very much for listening to me. I hope it was useful, and I did my best. Have a wonderful day. Thank you.
I believe so. Thank you, Dariush, and thank you to everybody. Let's see here. Would you be able to answer a few more questions, Dariush?
I'll be more than happy, yes.
Okay. Let's see here. So, let's see. Here's a question. Doesn't cycle and soak and adjusting your runtime to match your infiltration rate help with develop a deeper root zone?
As I said. Yes, doing that will prevent the soil to be saturated with water, because when the soil gets saturated, then it doesn't go down immediately, and it starts running on the surface. Yes, proper cycling will help a lot.
All right, perfect.
Depends
well,
on the type of controller that you have. Some of the controllers do not have that much of ability, so you must be careful. Yes.
Okay. What about are polymers such as dry water effective in holding water in the soil?
But tell you the truth, I don't know very much about them, and I know some, but not that much to advise about them. So I apologize about it. Yeah.
Well, that appears to be all. So thanks again, Dariush. Very informative, obviously very educated. So thank you for your time, and thanks for the 50 people that joined us today.
Thank you very much to all the 50 people, and you, and Crystal, and Farmers, and Lampix for giving me this opportunity, and I'm pleased. By the way, this is going to be on my web page as well, which is ecoconsulting.com, and I have another web page. It is pomegranatesociety.com. Both of those will contain this information in a more detailed manner, and I will send an email to Landfix to announce that, and you are always welcome to use it or contact me for. Have a wonderful weekend.
Great. Thank you. Goodbye, everybody. We'll see you
Bye-bye.
next
Thank
time.
you. Thank you.